So as a recap, the mean value theorem says that the instantaneous change, that f prime of c, at some interior point must equal the average change over the entire interval, that secant line. So here's an example of where this actually happens in the real world. Shocking, I know. So it says if a car accelerating from 0 takes 8 seconds to go 352 feet, its average velocity for that 8-second interval is blank. Well, so we've got two ordered pairs here. At time 0, you've obviously gone nowhere. But then at time 8, you've gone 352 feet. So the average rate of change, 352 over minus 0 over 8 minus 0. So 352 divided by 8. And we get 44 feet per second. Now, our cars don't measure in feet per second, so I want you to do the conversion to how many miles per hour. And it ends up coming out to 30 miles per hour. So when I did it, it's 44 feet in 1 second. So we want to convert feet to miles. And so there's 1 mile in 5,280 feet. And then we want to convert seconds to hours. There's 3,600 seconds in 1 hour. So when we do our unit conversion, you're left with miles on top and hours on the bottom. So we get 30 miles an hour. So where you first thought it was actually quite impressive, it's really not that impressive, that in 8 seconds it gets up to 30 miles per hour. And it says at some point during that acceleration, some point, this is your C, the theorem says that the speedometer must have read exactly 30 miles per hour. So our average rate of change was 30 miles an hour. That means at some point in that time frame, the speedometer also had to show 30 miles per hour. It's not going to magically jump over 30. So at some point, it had to go 30. So geometrically, the mean value theorem looks like this. So you've got your secant line from A to B. So G of B minus G of A over B minus A is the slope of the line segment that joins the 2 points A, G of A, and B, G of B. It finds that average rate of change. Now there's a typo in your note packet. This should say G prime of C. And G prime of C is the slope of the line tangent to the curve, G of X, at the point C. Now notice in this picture there is no point C. So the secant line goes from A to B, and you can see it's got a negative slope here. And so number 3 says locate the value of C that is insured by the mean value theorem. And it says there's one such value, and it tells you it's about 2/3 of the way down the x-axis. Now, all we're looking for is where does the instantaneous rate of change equal the average rate of change. So I need to find where is the instantaneous slope the same as this slope. So I'm going to just kind of turn my paper a little bit. It would help if I had a ruler. I don't. So I'm going to just kind of approximate the slope of the tangent line at this point is parallel to that secant line. So I would say there's my C, and I would agree it's about 2/3 of the way over A and about 1/3 of the way up on B. So then a couple of definitions here, and these are going to be the solid definitions for the rest of this chapter that we're going to be working with. It says, let f be the function defined on some interval, and let a and b be any 2 points. We know that f is increasing from a to b if the function at a is smaller than the function at b. It means it's going to go from a smaller value to a higher value. That's increasing. The opposite is true for decreasing. If the function is bigger at A and smaller at B, then the function is decreasing. So then there's this corollary. It's kind of an add-on to that definition. And so they wanted to take it one step further. And it says, what if f is a continuous differentiable function on a closed interval? Then it says, if the slope is greater than 0, if f prime is positive at every point, then that guarantees that f is increasing. So I want you to take that highlighter, and we're going to highlight, if the slope is greater than 0, then f increases. The opposite is also true. If the slope is negative, then that means the function is decreasing. So we've talked about that already in previous sections. Now it's in writing. So how does that help us out? Well, it takes me to my favorite function, y equals x squared. And we don't even need calculus to do this question. If I were to graph x squared, it's just a normal parabola, goes through 0, 0. You could look at this graph and tell me it's decreasing over here and it's increasing over here. So we would say it's decreasing when x is less than 0 and it's increasing when x is greater than 0. But if we use the lesson stuff from section 1 where they said find those critical points, the derivative doesn't ever not exist. So we need to know, where does f prime of x equal 0? Well, the derivative is 2x. And so if I divide by 2, we get a critical point at x equals 0. So if you remember, we talked about those sign charts, and I used f prime to come up with this value. So if I plug in a number to the left of 0 into this derivative, if I plug in like -4, 2 times a negative gives me a negative. And if I plug in a positive number, 2 times a positive gives me a positive. So this sign chart tells me here it's negative. The derivative was negative, which means f is decreasing. And here I've got this positive slope, which means that f is increasing. And that matches what we said over here. So using that technique, using a sign chart, using those critical points, I want you to decide, where is the function x cubed minus 4x increasing and decreasing? Use a sign chart. All right, so breaking this into steps, the derivative was 3x squared minus 4. We set that equal to 0. This is a continuous function with no weird asymptotes or jumps or holes or anything, so there's no place where the derivative doesn't exist. So when I add the 4 and divide by 3 and then take the square root, I get plus or minus square root of 4/3. There's 2 critical points. Now use the sign chart to help you find out, where is the function increasing and decreasing. So when I use those values, I plug in a number to the left of negative square root of 4/3, like -10, and that gives me a positive number. If I plug in a number in between, like 0, if I plug in 0 in here, I get a negative number. And a number bigger than square root of 4/3, I get a positive number. So what that sign chart tells me is that f of x is increasing when x is less than negative square root of 4/3 and when x is greater than positive square root of 4/3. And we know f of x is decreasing between negative square root of 4/3 and square root of 4/3.